Hi, this is part 2 of our building neural network in order to classify monkey images. This is the link for the full playlist. So today we are going to continue with the next step. After we discover the data and the images, we are going to build a convolutional neural network in order to classify the monkey species. As we mentioned in our first part, there are 10 classes, and we are going to start with importing some libraries. I'm not covering the installation, the pip install files. You can see it, which libraries I'm using with our import commands. Tensorflow, of course, is the basic one, but we are going to use some more libraries. So first of all, we are going to use Keras preprocessing image and image data generator for data augmentation, and some more Keras libraries and functions. So please follow this tutorial. We are importing more Python libraries to our code. For example, we are importing NumPy and matplotlib in order to display the outcome of the model. Let's run it to see that we don't have any errors with the first part. Okay, everything okay, so let's continue. Let's define some global parameters for our code. Our image size would be 200 on 200. We have 10 classes, which are basically the 10 monkey species. Our batch size will be 32, and we will run 25 epochs. You can see later that we are going to play and change these arguments. Now we are defining our model. It will be a convolutional neural network model. That means it's a sequential model. Now let's define the layers. In this tutorial, this part 2 tutorial, we are going to define the layers and the number of filters from a previous experience. However, we are going to use in the next tutorial the Keras hyperparameters to tune these parameters and to try it on different steps and different arguments. But as for now, let's build our model. So the first layer will be a convolutional 2D layer based of 32 filters and the kernel of 3x3. I hope you are familiar with the structure of a convolutional neural network of classifying images. So the next layer, of course, will be a max pooling, a 2x2. Next, we are going to create a new convolutional 32 filters layer, and the next one will be a 64 filters layer, and another 64 filters layer, and then we are going to flatten our layers, our neuron. We are going to add a dropout to reduce any overfitting. As for now, we are going to use it as 50% of the neuron. As I mentioned earlier, next we are going to try and hyperparameters, and this will be one of the parameters that we are going to play with it to understand if 50% is a good number. Next, we are going to create a dense layer with 512 neurons. This would be another number that we are going to play with it in our next tutorial. And the last layer, of course, is our classification layer based of 10 neurons. This is the num of class variable, and the activation function will be softmax and not a ReLU. This is a common practice. Okay, we have a syntax error. Let's fix it. Okay, it's from models, then run it again. Okay, let's print the summary of the model. Let's see all the layers. Okay, now you can see our model. The last layer, of course, is our 10 classes. Now let's compile the model. Our loss function will be categorical, of course. It's not a binary, it's a categorical since we have 10 classes. We are going to use the Adam optimizer. The Adam optimizer has a default learning rate, and next we are going to change and play with this rate as well. And the metrics, of course, will be accuracy. Let's run it again, just to figure out that we don't have any errors, and continue to the next step. The next step is dealing with the data. Since we don't have much data, as you can see, in each folder we have about several hundreds of images. We are going to use the data augmentation method from the Keras out-of-the-box functions. So first of all, we are going to build an image data generator, and these are the arguments for this function. We are going to do some rotation and some zoom in, and this will help us to augment the data and basically enrich our data for the training. So we are going to build this image data generator for the train and for the test as well. As for the train, we are going to manipulate the data. We are going to do some changes and enrichments in order to create more images. This is the zoom range and the width shifting and the height shifting. And of course, we are going to rescale the data since the values are between 0 and 255. We are going to divide it to 255 to normalize the data between 0 and 1. And then we are going to use the function to load the data from the folder. Okay, this is the function flow from directory, and there are several arguments that we are going to use in order to load the data. First of all, of course, it's the name of the folder, the training folder. Then we are going to shuffle the information. This is very important to shuffle all the images. As for the test that we are going to update it later, there will be no shuffling. We are going to change the size of each image to our image size. Please notice that every image has its own size, has its own dimension. So we are going to normalize the size of all the images. The batch, which is 32, and of course it's a categorical since we have 10 categories for the monkeys. As for the test, we are just normalizing the data between 0 and 1, and there will be no shuffling. Of course, we are going to change the test to our test directory, and no shuffling for the image. Okay, let's continue. Please notice that I forgot to update the training set to a test set. I will fix it later. Next, there are two important variables: steps per epochs, and the steps for the validation. It's a very simple formula, and we are going to round the outcome of the formula to an integer, but to the up value of this integer. So we are going to use the seal function, and then the validation steps as well. Here we are fixing the name of the variable, as I mentioned earlier. Let's define the name of our model. We are going to store the model as an H5 file in the same directory. Okay, this is the name, my CNN monkey model. Next, we are going to use the library of Keras, the callbacks library, and we are going to use the function model checkpoint. And basically what we are going to define that each time we are getting a better result in our validation accuracy, we would like to save this model to our folder. So this is the way to do it. Let's run it again. We are not running yet, just to see that we don't have any errors. We will use this best model variable next in our training process. Okay, the function Feit is the training. We are going to pass our training set. This is the first argument. Then the validation set. This is the next argument. Number of epochs. In our first try we will try 25 epochs. According to the result we will change it later. Then the two more variables, steps per epochs and the validation steps. And let's define our callbacks. Our callbacks will be the variable best model, as I mentioned earlier. Each time we are improving our model, we will save it to the disk. And of course the name will be my CNN monkey model.h5. After the training, let's evaluate our results. We will use the evaluate function. We'll pass the test set and we will see, let's print the results, and we will see the loss function and the accuracy as well. The last step is displaying the results as a chart. We are going to use the pyplot functions. So first of all, after the training, we will retrieve some variables like the accuracy, the value accuracy, the loss, and the validation loss. We are creating another variable actual epochs. Since we are using the range function, that means it will be between 0 and 25. And let's print it. Now we are plotting the results. The accuracy will be in a red color. This is the R, and the label will be the training accuracy. The other line in the diagram will be the validation accuracy. And we'll change the color to black. Let's put a label for the X and label for the Y. Of course, it's the accuracy and the epochs. You can put a title for the diagram. And show it. Okay, we are ready. Let's run it. Let's start the training. So this is the first epochs. It's going to run for 25 epochs, but we are not going to wait until the whole process. We will do a fast forward process and run directly to the end. As you can see, it's a fast forward. Let's wait a few more seconds. Okay, so we have the result. You can see the training and the validation accuracy, and we can see that the validation is going down, so probably we have to do some fine-tuning. So let's change the augmentation and create more images or create more manipulation on the images. And moreover, let's try to, if we are changing the manipulation of the data, let's add more epochs. Let's give it more time to train. And it's very important to understand that if we were not changing the data augmentation, probably we are not getting a better result. Since we are changing, basically creating more data, it's okay to add more epochs to the process. So once again, we are on a fast forward process, and now for 30 epochs, and let's see the results. You can see during the running, each time the val accuracy is getting better, the model is being saved. As for now, you can see that it's a much better model, much better results. The validation accuracy is 71%. It's better from our previous results. Now let's test our model. Let's try to show some of the images, like random images, and put the text of the real label next to the predicted label, and to see it next to each other, and basically to see the test of our model. So we will copy some of our coding. First of all, we are going to load our saved model. Let's load and print the summary just to see that the loading process is okay. We should see all the layers. Okay, the loading is perfect. Now let's import more libraries. We need some of the Keras in our global variable for the testing as well. Let's copy the name of the folder, of the test folder. Of course, we don't need the data augmentation, but we need the image data generator, the one that creates the rescaling between 0 and 1, and loading the data. Let's run it. We should see the number of images inside the folder that are divided to 10 classes. And now let's go to the prediction. We're going to use the predict function. We're going to pass the test set, and the prediction will be the results of the prediction of all the images in the test folder. Let's print the type of this variable predictions. So basically it's a NumPy array, and there are many numbers. What are these numbers? These numbers are basically, for each images there are 10 numbers, 10 predictions. So what we need is the best prediction for every image, which is the highest score for every image. So we are going to use the argmax. It's a NumPy function. We are going to run it for all the predictions. So if we'll print again this variable, prediction results, we can see that for every image, and basically we have, as we saw earlier, 272 test images. For each image we can see which label or which index in the label is the highest one. For example, for the first image, the prediction is 9. 9, that means from the 10 classes, the index number 9 will be the prediction for this image. So now let's copy our code for getting the name out of a label. We need the common name, and we create it in our first part of the tutorial. So let's copy this code, and we will send the outcome of the prediction to the monkey dictionary, and we will get the name of the monkey, the name of the class. So in order to do that, we are going to load random images. We are going to create like a matrix of monkey images, and next to each image we will show the real label and the predicted label. So we will have 5 rows and 6 columns, so basically 30 random images, and as I said, for each image we will show the real name and the predicted name. So you can follow this tutorial, how I can create this function. I will do a loop inside the folders, a very straightforward process. Of course, I'm going to leave all this code in my GitHub repository. You can use it for this tutorial and other tutorial. You can use this tutorial for many types of convolutional and neural network classification problems. we are going to display only the first 7 characters, since we don't have enough space for displaying the full name of the class. As you can see, this is the predicted name and the real name. I'm also calculating the number of success, and we will print it in our log. Okay, the last process is printing how many images, the total images, and how many correct images we have found. And showing all the images. Okay, let's run the function. I have some syntax error. I forgot to add the import glob and some commas. I hope you're following the tutorial, and of course it's not show, it's I'm show. Let's run it again. Okay, these are the images. We have loaded the 30 images. 25 of them are a correct prediction. You can see it's one next to each other. Our next tutorial will be how to use the Keras hyperparameter to fine-tune our model, a very important lesson. Thank you.